Hello. Good God. This is one of those nights where Crash had to rush through his dinner in order to make it to stream on time. Thankfully, I didn't choke on like a bone or anything. I wasn't that ravenous about eating my food. So, I'm still alive, and I think that's a net good for the world, or at least for you all. So, there's that to celebrate. Let me just switch on over here, and there we go. Hi, good evening, everyone. It's time to digest some chemistry. So it's been a while since I've done more chemistry stuff on this channel. There hasn't been a lot of new uploads in the chemistry sphere recently, and the ones that have existed just kind of have come up at inopportune times. But, recently there was a good handful of videos from some of my favorite chemistry YouTubers. NileRed, Explosions and Fire. You can even see him over in the recommended here. And maybe I'm a little bit late to them. It did release like last week, but I think this is a fashionable amount of delay in between starting up between that upload and getting this stream scheduled. I'm excited though. For anybody who is not so familiar with NileRed, he is a Canadian scientist. He likes to do he owns his like own lab to like do all of this YouTube stuff. Like it's kind of all self-funded, which is crazy. All things considered, Mans owns a whole chem lab with all this expensive equipment. And he is one of the most popular chemistry YouTubers out there. If you have any knowledge of the chemistry YouTube sphere, it's probably this guy. And it's because he's known for doing a lot of unusual transformations. He does well, you could see many of his recommended things on the side: turning paint thinner into cherry soda, turning plastic gloves into hot sauce. And today we are going to be doing, and let me put on a little bit of background music. Today we are going to be listening to the recent video on turning glue into drinkable alcohol. Now this one struck me as a little bit unusual just because of the fact that, like, a lot of these videos are often in the realm of like, oh, the complexity of the molecule that he's going for remains about the same. Or it goes up a little bit higher. He adds more molecule or adds more atoms onto it, makes the structure a little bit more complicated, that kind of thing. This one is weird though, considering that ethanol is one of the simplest molecules I can really think of. All it is this collection of atoms. If you could look over to the screen on the right there, it's wait, that's methanol. Whoopsie. Let me fix that and show that I have a chem degree. All right, wrong layer. I forgot how I usually do this. Draw that real quick, but it's just two carbons together with an oxygen and a hydrogen at the end here, and a bunch of other hydrogens sticking out every which way. It's what gets you drunk. And it's like extremely, extremely simple. So like, before, NileRed has made like toilet paper into ethanol, and that makes sense, right? Like that's kind of on a similar pattern of like just fermenting some kind of cellulose thing, like sugars. You just break the cellulose down, that's made up of that the toilet paper is made up of, into smaller monomers, the cellulose turning into sucrose. You ferment the sugar and you turn that into alcohol. And yeah, that's going down in complexity, but like it kind of makes sense, right? That's what humans have done for a lifetime to, imbibe God's Icar, and get themselves in a bit of a stupor. Yet this is like, I have no idea what is particularly in children's glue. I'm sure he's going to explain it, and I'm interested in how that's going to go. But like, it's hard for me to think of something like, well, what would you want to easily decay down to ethanol when you could like it's just so simple. You can get it from anywhere. Like, what point are you proving here? So I think I've delayed long enough and would love to start getting into it now. So let me go pause the music and we can go and take a look. I will be trying to provide any assistance with the chemistry on the right screen over there as the video goes on. And I mean, usually he does a pretty good job at explaining things, but I like to supplement. Try to make my reactions a little bit more than just kind of a live zombie reaction type of thing. Hey Grim, the trifecta of yummy children's food: glue, crayons, and Play-Doh. That is a pretty good one. You forgot the fourth yummy child's food, which is just like basically anything that'll fit in their mouth, especially dirty live little animals like mice and birds. Somehow kids will manage to get a hold of those things, and then they are going to have the absolute worst virus in their system for just like a whole month. It is disgusting. Anyways, let's get on with it. Oops, I muted the video. I had to mute things temporarily so that way we could skip the ground news sponsorship. Shush. Don't tell anybody I'm skipping sponsorships for you guys.
Projects where I turned completely inedible things into food, like that time I turned plastic gloves into grape soda and hot sauce, as well as that other time when I turned cotton balls into cotton candy.
Play-Doh burger
What I've
tasty,
been really
true.
wanting to do for a while, though, is to try turning children's glue into drinkable alcohol,
Now, why would you
and
want to do that?
at least in theory, this should be possible. This is because the main ingredient in most children's glue is a
Sponsored by
plastic
Elmer's.
called polyvinyl
Oh my
acetate,
god.
or PVA for short, and in its chemical structure, it contains all of these little groups here in blue, which are known as acetate groups.
They
On their
certainly
own,
are.
they aren't too special, but what I think is really interesting is that it should be
Hey, Bingo
possible to
Bongo.
pull them off
We
the
love NileRed, yeah.
PVA and to turn them into something known as acetic acid, which is essentially pure vinegar.
Huh. Alright, I mean, that's kind of an interesting synthesis pathway. That kind of makes sense. So, I was not expecting that. That's, I think, not that it matters very much, but I'm intellectually satisfied with the scope of this project. It's kind of neat to think like, oh, well, let's actually turn a very common plastic compound, break it down into its components, and then from there, what he's going to explain soon is that he's going to reduce the acetic acid, basically get rid of this double oxygen carbon bond in the middle here. I think you can see my mouse. And turn that into just two hydrogens. And I gotta say, well played. That's an unexpected use of polyvinyl or of polyvinyl acrylate.
Then after that, with just a bit more chemistry, I should be able to convert this acetic acid into some pure
I know, right? It's
ethanol,
awesome.
which
It's so cool to see how
hopefully
like all these materials are
would be
related
safe to
somehow.
drink. With that being said, though, overall, I just thought that this whole idea sounded pretty fun to do, and I was also really curious to know what children's glue alcohol would taste like. So,
I thought for a second he was just curious what children's glue would taste like. If that was the case, he didn't have a childhood, but
despite the
that's
fact
neither
that
here
I
nor there.
wasn't exactly sure how to do it, and that I very possibly might end up just completely failing, I decided to just go for it. So I just went ahead and got started, and the first thing that I was going to need was, of course, some children's glue.
Where are we going to get
and I ended up
children's
going
glue
with
from?
Elmer's, which seemed to be the most common one. I also decided to go with a full gallon, which is about 3.78 liters, and this may seem like a lot,
Thanks for the
but
conversion,
I had
Nile.
absolutely no idea how much PVA was actually in here, or how efficient the process would be.
Probably not
But with
efficient.
that being said, now that I had the glue, it was time to try turning it all into alcohol, where the first step was to get a large dish and to start dumping it in. This was because before
If someone can make marshmallow peeps wine, glue alcohol doesn't sound too far-fetched to you. Yeah, but like Peeps wine like was the thing that Peeps wine to me at least makes immediate sense because like, oh, that's sugars. Like the sugars are normally converted to alcohol anyways. Like that's perfectly, logical. It's just kind of a sidestep to that. This is a little bit of a logical leap, especially when I didn't think to like, oh, yeah, let's take the plastic specifically in glue, get rid of the fun groups on it, and then turn that into ethanol. It's wild.
doing any chemistry, I was gonna have to get rid of all the water that was in the glue, which was at least around 50% of its volume.
The water really
I
going to
also
interfere
figured
that
that this was
much?
going to be really simple and that I basically just had to leave it out to dry. and I assumed that this was going to go relatively quickly.
Why would you assume the... I mean, I
However,
guess
that
glue
was
does
not at
dry,
all the
but
case, and it
that...
turned out that drying glue like this was excruciatingly slow,
Well,
mostly
yeah.
because the surface of it just quickly formed a really thick layer, which prevented the water below it from evaporating.
So one of my favorite things about NileRed is just that, like, he somehow lacks very simple arts and crafts and also cooking knowledge for some reason. This man will turn plastic gloves into cherry soda, but he has also done a like 40-minute video attempting to roast coffee beans and failing to do so in a coffee roaster because he burns the damn beans, and he's too strict on following the recipe instead of like following his nose. And so I'm like, yeah, of course the glue, if you just put it in one solid mass, it's going to turn into either a gigantic block, or B, it's going to have a thick skin on it. If you've ever dried glue, you know that the center always dries last. And if you're a chemist, you should think like the air doesn't penetrate in. It's funny to me. It's funny to me, damn it. I believe that's called having autism. Well, you are the expert on that, Grim, so you're qualified to say that. At least you can go one step further, turn a horse into wine. I don't think it's that crazy. No, you could probably turn a horse into wine. You just have to extract all the sugars from the horse. It wasn't even meant to be a goddamn, and Grim has said that before, but
and
appreciate
revealing the fresh wet glue below it. I
So he
also
really
set up a
struggles
fan
with drying the glue?
off-screen
Oh,
in
God.
an attempt to make this all go a bit faster.
Yeah, that's
And
expected.
at first, it seemed like it was gonna work.
Oh yeah, which also that's like my thing where I'm thinking like, why is he really bothering to dry the glue? Because like, I'm sure there's like other stuff in the glue that will like mess with his like plan. But if I like really crudely draw out like the PVA here real quick that he was like demonstrating earlier, like the PVA was roughly structured like this, I believe. Do that. Draw the acetate group. This is the drawing is going to be very, very scuffed, but bear with me here. Oh, da da, draw two more of these groups just for demonstration purposes. Like I'm putting the synthesis together in my head right now, and what I'm thinking is like, he just needs to not dehydrate this, but like do a what's the word for it? Like an acid lysis, where basically just by adding acid of a very strong nature, you could have that kind of be attacked, or the oxygen's electrons could just attack the hydrogen, the proton here from the acid, and eventually that's just going to cause the carbon oxygen bond here to cleave, and that'll just eventually yield you, plenty of your acetic acid that you want to get. And then just like, plus shitty plastic. And like, you don't need the shit plastic. You just need the acetic acid. So like, why not just mix glue with a bunch of sulfuric acid and like filter out the tar and just like take that? I suppose that would be too easy, and I'm sure there'd probably be other problems with it, but that's what I would do if I was trying to do this at first. So then you can extract all the sugars from a horse. If the MLP characters were real, they'd probably make really good wine. True, they do look like they look Peeps flavored, so. Terpsies wine, pure ethanol. Yeah, true. Or whatever the liquid form of galaxy gas is. Well, technically, galaxy gas is just like nitrous oxide, and so like if you just got that cool, you could get it into a liquid form. So, chemistry. Is there a pony that makes Four Loco? God, my pony knowledge is not very strong. I'm gonna go with Celestia and leave it at that random ass guess. Anyways, glue drying. He's so entertaining.
However,
it's like watching glue dry.
It only kind of worked, where it did definitely make it go faster, except even after 14 days of flipping it over and over, it still wasn't fully
Yeah,
dry.
yes, Niall, you're
It was only
drying
after
layers of
wasting this
glue.
much time, though, that I finally accepted that this was an absolutely horrible method that would probably take at least a few more months, and it was pretty clear
Few more
that I was
months.
gonna have to
Oh
try
god.
something else. So I decided
You're
to
gonna add
basically just
acid
do
to it
anything that I
anyways.
felt would speed it up,
It
where
has
the first
water.
thing that I thought of was to chop it up like a large cheesy lasagna, which I thought would really help the moisture escape.
Oh, he's not
I then
wrong. That is
tossed the
kind
whole
of like a
thing into a food
lasagna, but I don't
dehydrator
want to think
to
about
heat it
it.
up, and after a full week, it
Glue
was
brownies,
looking
true.
significantly better.
These are the most blonde
However, after
blondies you've ever
manually
seen.
tearing off some of the glue
What
and
the?
peeling away the rest with my multi-tool,
What the
it was
fuck?
obvious that it still wasn't fully
What are you
dry.
doing? Why do you need a saw to get your glue out of the tray? Oh my god, Niall! I guess
And
it's
I'll be
stuck to it,
honest,
but like,
after waiting almost a month already,
how did
I
he
was
burn
really
it?
tempted to just consider this dry enough. As one last-ditch effort, though, I decided to try putting all of it into my new vacuum oven
Why wasn't the
that I
vacuum
just
oven the
happened to
first
get
thing?
earlier that week.
Okay, earlier that
With it
week.
all
Fine.
loaded in, I
Fine,
then
that makes
pulled
more
a
sense.
vacuum on it, which would make it way easier for the moisture to escape
Yeah,
the
that
glue.
that blade is
And I
done
ramped the
for.
temperature up to 80°C.
Oh god.
I also kept it there, and I didn't raise it
Full
any
of glue.
higher,
His
because at
lungs are
least from
probably
what I
full of
read
glue with all
online,
that
anything
dust.
hotter could potentially cause the PVA to start degrading.
Alright, yeah.
But either way, as the glue sat there, it did slowly get drier
Oh,
and
time
drier,
lapse.
and eventually, after several more days, it seemed like all of the water had finally been removed.
Swear to god, if you
So
mix
I
this
took it
directly
out,
with
and
acid
now,
afterwards.
after what was way too much effort and work, what I was left with were some super
It does
dry
kind of look like a New
blocks
York cheesecake,
of
Grim.
what
It's
was
got that brown
probably
top,
nearly
actually. You're
pure
so right.
PVA. At this point, it was also probably as dry.
Wait, hold on. Did he just say that's ultra pure PVA?
What I was left with were some super dry blocks of what was probably nearly pure PVA.
Okay, nearly pure PVA. So there's not anything else you're going to extract from it. Never mind the burnt blackened bits, but there's nothing else you're extracting from this. You just... Why did you... You're gonna mix this with an aqueous solution, Niall. Why did you get all the water out?
At this point, it was also probably as dry as it was
Probably
ever gonna get.
nearly. Good God,
So
I know,
I
right?
just went and got my multi-tool.
I mean, to be
and I
fair, he doesn't
fully
need
chopped
to
it
be
into
precise
pieces.
about the purity, but still, it's like, come on. There's a certain level of nonsense to this that's in my mind.
This then left me with a bunch of rock-hard blocks of glue, which I was pretty happy with, and after weeks of kind of wasting my time, I was especially glad that this whole drying part was finally done. The only unfortunate thing was that the
Oh no.
struggle wasn't quite over,
Yeah?
because all of this PVA was actually useless to me
Oh,
as these large chunks.
okay.
This is because
So you're
to
gonna
do
grind it
any
up.
real chemistry with them, I was gonna have to be able to get them into a flask,
You
which
really...
meant that they would have to be way smaller.
Yeah, you know, if he also
This
got
in
a new
turn
hammer
meant
that
I
week,
was
he would have
gonna have to
absolutely
break
used it
them into
too.
a bunch of tiny pieces, and at first, I thought this would be relatively easy, and I figured that all I had to do was get a cheap food processor and to
Oh,
shred it like cheese.
that's your first mistake.
However,
You
another
bought a
long
cheap
story
food
short,
processor.
that was absolutely not the case, and I ended up completely dulling out the blades and kind of breaking the machine. Uh-oh. I then moved on to ruining the blades in my blender, which also totally failed to break it apart.
And you didn't want to
And when I
hold the cap
completely gave
on?
up and
Just want to let
started
that
just
fly
smashing
out
it
like
with
a
hammer,
sticky brick?
the
There we
only
go.
thing that I was able to break
It's breaking out the hammer
was my
method.
table. No! My table! That's not good.
Oh, this is
So
going to be
clearly,
great.
this glue was a lot tougher than I expected, and at this point, I was starting to worry that I might have to
If only
spend
he had some
hours
glue
and
to fix his
hours
table.
manually chopping apart the squares using the multi-tool, which sounded absolutely horrible and probably wouldn't even work very well.
I feel like you own
After
a
a bit
ball
of
miller,
thinking, though,
Niall.
and
You want to put it in
searching
a ball
online,
miller?
I ended up finding what I felt was the perfect solution, and after a few days of waiting, I became the proud owner of the cheapest wood chipper that I could find on Amazon.
Well, that yes, this will work too. Um, I guess for those curious, the thing I just mentioned, a ball miller, is typically like if you ever seen a rock tumbler, it's essentially kind of like that, a nice cylindrical item at an angle that like rotates for a long period of time, and it has like little some like metal shot of some kind, real small cylinders. You basically put whatever you want to like grind down in there or flake off, and just like let that run for like 2 weeks, and the metal balls will, routinely hit the item and break flakes off. You would usually do that with like hard metals, trying to break that down. But this works too. A wood chipper is fine also. We want to go the Fargo method. That's what Nigel's known for.
Then, when I felt ready, I went and got all of the glue and turned on the chipper, and I was somewhat concerned that the glue would still manage to destroy it.
It's kind of like an ordinary sausage video
fine,
when he tries to like force like horse bones through his fucking grinder, and it just ruins everything.
Do all of this manually.
All right. Well, good luck to you there, Niall.
It was satisfying to see each piece getting sucked in and obliterated by the blades, and over the next few minutes, I had a lot of fun dropping in the rest of the glue.
That does look fun, though.
The only problem was that
still
when
big
I
chunks.
was eventually done, it was very clear that the pieces were still way too big,
All right.
and to get them smaller,
time to buy
I was gonna have to pass them through again.
Time to buy a slightly smaller wood chipper.
Unfortunately, not quite as fun or fast, but it did work, and I decided to just keep putting everything through the wood chipper over and over.
Oh, it does. It actually looks like finely aged Parmesan. Actually, the color is even perfect for it. It looks like 20-month-old Parmesan.
The limit of what the chipper was able to do.
The forbidden cheese.
And what I had now was a beaker full of small chunks of PVA, and what was nice was that they were all pretty much exactly the size that I wanted them to be. It was also very nice that this had only taken about 20
I opened
minutes
a window
instead of hours and hours of tediously chopping everything myself, and I'm very happy that I invested in the wood chipper. Moving on, though, with all of the glue now ready, I could finally start doing the chemistry to turn this into some hopefully tasty alcohol, where the first step was to turn it into pure acetic acid. From a bit
Sweet. Hold on the cheese topic though. When I think of the forbidden cheese, let's see. This is the image that I think of. Go to my downloads. There we go. Resize that. God, that's a big image. I always think of this. Semtex is the real forbidden cheese. That's where the adults play. Dried glue, that's kiddie shit. Adults play with Semtex 11. Anyways.
Research, it also seemed like there was probably a few different ways to do this, but from what I could tell...
Oh, did he? Oh, no. Niall's usually so good about doing the research before he starts a project. Usually he starts a project because he finds, like, a paper and thinks, wait a minute, I could do that, and that's kind of a cool idea. Let me do that. I swear if he's about to read a document that tells him to dissolve it in acid, I'm gonna be so disappointed.
The best and easiest way was to basically just heat it up.
Oh, okay.
So that was what I
just to heat it.
Do.
Okay, that's a little bit more reasonable.
I just
but still,
quickly transferred all of this glue into the biggest round bottom flask
Nile,
that I had.
Nigel, you could dissolve it in sulfuric acid, Nigel, and then just distill the acetic acid, Nigel.
In place, and I continued putting together the rest of the setup by first adding a 3-way adapter with a thermometer in it, followed by a condenser column. With all of this in place, I was then able to
2,000-year-old wheel of cheese.
And
that's got to be some good Parmesan.
This was what I had.
Some good Romano.
So the flask here was where I was hoping to collect the acetic acid, and the tube here was connected to my vacuum pump. This was very important because this all had to be done under vacuum and without any oxygen present. Otherwise, the glue would probably just burn or become a crusty, charred mess.
Well, you already kind of messed that part out, Nigel. But yeah, okay. So I guess what he's about to do makes a certain degree of sense. Like, it will work. It'll just be a little awkward. He heating it up will allow some of like the hydrogens that are implicitly on all these carbons to like move over to the oxygen and like cause let's see, cause some other electrons to move, causing other hydrogens to kind of move elsewhere. It's that this the diagram isn't right, but it will like kind of it will cause rearrangements so that way some of the hydrogens from the actual plastic jump ship onto these acetate groups, and you'll like probably get like some weird like polyethylene kind of solid where it's like these are carbons double bonded to each other and then connected to a single bond, and then that keeps going and then more double bonds, etc., etc. So like this method makes some sense and I guess has the benefit of being a little bit more environmentally conscious. I mean, as environmentally conscious as turning glue into ethanol is. Um, you're not using a whole bunch of like super like corrosive and toxic acid, so like that's good. But it does seem maybe a little bit convoluted, and also not to mention all of the energy that probably went into drying the glue in a conventional oven and then a vacuum oven and then putting it through a wood chipper and using a multi tool. Um, Sorry if I'm complaining a lot. One of my favorite things to do when watching a NileRed video is kind of be like, why is this the procedure you chose? Because usually I'm like looking at this, I'm like, this has got to be one of the weirdest ideas I've ever seen. Like I would do this differently, but to each their own. And he has the millions of views, so he knows what he's doing.
With all that being said, though, I was just about ready to get started, and the only other thing that I still had to do was wedge a thermocouple between the flask and the heating mantle. This would allow me to monitor the temperature, and it wouldn't be super accurate, but it would still give me a decent reading of
True.
how hot the flask was.
Oh yeah.
Now,
Also, I guess the vacuum part is important too because it will help bring the acetic acid over at a lower temperature. Chemicals will boil. So for anyone who doesn't know, a chemical's boiling point is like we would normally think of the boiling point of water at 100 Celsius. And we also know that like it will lower at higher elevations because the atmospheric pressure drops. So fundamentally we're doing a similar concept here where acetic acid has a boiling point of like what is it? I can look it up real quick. BP. It's 117.9 Celsius. So by putting that under vacuum, a significant vacuum, he can probably lower that to something like, I don't know, say 60 or 70 Celsius, depending on how low the vacuum is, which will help prevent, that burning kind of effect that he was describing. So solid distillation type work.
with all of this in place, it was finally time to start cooking some glue. And to get things going, I
Glue.
started by flipping on my vacuum pump. I then turned on the heating mantle as well, and I raised the temperature dial only slightly because the goal now was to heat things relatively slowly. This meant that at first, not much was going to happen, and well, over the next 10 minutes, I really didn't notice much of a difference.
Yeah, I mean,
When
it's
it
just getting
eventually
hot.
got to around 70°C, though, I started seeing some fogging down here,
Ooh, the
and
forbidden
not too
fog.
long after,
The
I
fog is
saw the
coming.
first drop of liquid fall into the other flask. However, when I looked over at the thermometer, which was showing me the boiling point of
Oh,
the
please
stuff that
tell me
was
it's more
coming
water.
over, I saw that it was only around 20°C,
Or not.
meaning that this was probably just residual water that was getting cooked out of the glue.
Funny,
It
see?
then
Water?
continued just like
Really?
this for the next 20 minutes or so, where I got more or less
How
continual
strong of a
drifts,
vacuum you pull in
and the
there, Niall?
temperature of the glue flask slowly increased.
I don't think
This
going
in
to
turn made the
20°C makes
drip rate
complete
increase
sense.
as
There's
well,
probably some
and when
other
the
crap that's in
glue
there.
eventually got
Some
to
other
around
additive.
160°C, the stuff coming
Or not.
over started
Alright.
turning yellow, which I
No.
thought was a very good sign. This was because it likely meant that the glue was starting to degrade, and even though what I was collecting was probably
160°C.
still
Alright, well,
mostly
that's
water,
above the
things were at
decomposition
least
point
moving in the right direction. But either way,
of
all I could
acetic
do
acid.
now was just keep waiting and hoping that the glue would really start breaking down, and well, eventually, several minutes later,
Ooh, it's very yellow.
that was exactly what seemed to be happening.
It kind of looks
This
like
was because
pineapple
at
now.
this point, it had not only become significantly more yellow, it was also starting to let off some smoke, which was then traveling through the rest of the setup and filling up the other flask.
Goddamn glue
I actually
gas.
didn't know exactly what this was, but according
It's
to a
glue
paper that I
gas.
found,
Scientific name.
most of it was supposed to be the acetic acid that I wanted, which was forming as the acetate groups on the polyvinyl acetate
Yeah, it kind of
slowly
does. It
got
looks a little
torn
nicer.
off.
It's kind of like how
The
more
rest
yellow
of this
egg
vapor,
yolks or more
though, was
orange
supposed
ones
to
look
be a
tastier.
bunch of other crap like acetone and carcinogenic benzene, which was forming as the PVA plastic in general was breaking down.
Yeah,
This
this
in
is
turn
gonna
meant that in the
kind
end,
of go
I was
crazy.
probably going to end up with a horrible concoction of nasty chemicals, which wasn't exactly ideal, except that was something that I could worry about later on. But either way,
Don't say
getting back to
nasty
the
chemicals,
reaction,
Nigel, like you haven't
I
worked with
quickly put
crazier shit
together a little
before.
ice bath to
Come on
try and
now.
help and condense the vapor,
Benzene's
and when
not
I
that
looked
bad.
back at the main flask, I noticed that the glue was significantly darker.
Yes,
From
because you're
there,
leaving
it then
garbage
only
behind.
continued to get darker and darker, and eventually, by the time the flask was at 200 C, it had developed a nice red color, and there was some nasty black liquid that had collected on the side of the flask.
Yes!
At the same
Tar!
time, the
I
liquid
love
that was coming
tar!
over had also gotten a lot darker, and just by the color, I could tell that it was filled with a bunch of horrible and potentially carcinogenic chemicals.
It's
However,
probably all
despite this, I
potentially
was still very
carcinogenic.
happy with how it was all going, because at least in theory, this was all still mostly acetic acid, and at this point, I'd collected a pretty decent amount. From what I could tell, the rest of the distillation was also relatively straightforward, and I basically just had to keep heating it until the acetic acid stopped coming over. I, of
Yeah,
course, had
makes
absolutely
sense.
no idea when this would actually happen, but after about an hour,
When your
the
flask is
temperature on
just
the
all brown
thermometer
tar, baby,
started
that's when
rising
it's
much
done.
faster, which told me that I was starting to collect something else. I think we're getting to a completely new fraction here.
I will say, to return to being a little bit of a bitch for a second, this is why I would have done the whole acid thing, because while, yes, it uses up a whole bunch of acidic chemical, it does also prevent, like, so this reaction where the plastic is breaking down, it is likely going through a free radical pathway, and by that I mean these bonds are, like, take a given bond, I'm just going to draw, like, the oxygen-carbon bond here. If you take a given bond, a bond is made of 2 electrons. See if I can't draw that better. That's close enough. So a bond's made of 2 electrons. It will homolytically cleave, meaning that it will have um 1 electron will end up going towards each atom. So a homolytic cleavage would end up looking like this. And another one on the carbon, where each of these dots are going to be electrons. And the free radical reactions and free radicals in general tend to kind of react with things pretty wildly. They are looking for another electron to pair up with and are often described in the literature kind of like just smash and grab looters. They are basically going to go to the nearest group they can find, grab an electron from it, and move on with their lives. This can often result in, well, if, like, say a free radical were to attack a bond, that can result in one of the electrons pairing up with the other electron, but then there's 3 electrons in that party, and so you kind of have 1 extra, and so you'll end up with like now you'll have another carbon radical here, even though you have this OH bond that formed, and so on and so forth. And so it's kind of just like the reaction is just kind of going to do whatever the hell is the fastest, bond as much as possible, and like it gets messy and you get like a million billion side products real fast. If you do the acid method, that's all 2 electron at a time chemistry, and that probably won't cause things to decompose as much. Maybe I'd have to test it, but that would be my guess because you're not having this crazy free radical chemistry that's going on. Hey, D prototype, you're so full from glue. Yum. Oh shit, you you pre-gamed for this one. I'm so glad. I'm proud of you. Hope you still have room for more glue though. We got rid of the water on this one. Should be absolutely potent for you. Yeah, we're right in the middle of this. His synthesis, NileRed synthesis. He decided to dry the glue, crush it all up, and then heat it a bunch to liberate these acetic acid groups, and he's going to turn that into ethanol. Because the glue is apparently made mostly of this big polyvinyl alcohol chemical. So, there we go. Pre-game glue sniffed. Damn. You might have pre-gamed for the wrong party. The glue sniffing party is down the road, but this is the glue drinkers party.
Most of this was still probably acetic acid, though, so I decided to keep collecting it until it got to around 120°C, which was over triple the boiling point of pure acetic acid
Hmm?
under the current vacuum pressure.
Oh,
At this
okay.
point, there was
I was about to
probably almost
say,
no
what?
acetic acid coming over, and the rate had also
117
slowed
is the
down like
boiling
crazy,
point of acetic
but I
acid.
still wanted to keep going, just to be absolutely sure that I collected everything.
Okay, you, Nigel. At a certain point, okay, if I keep switching between Nile and Nigel's because his actual name's Nigel and he's made this public, but like he, at a certain point, you have to cut the fact that you're just gonna be getting crap in your distillate. You've got to stop at a certain point. Going full on like this is just gonna make your product worse. Like you're gonna clean it up afterwards, but you're mostly just getting gunk at this point. Like stop, dude. Stop.
This didn't end up going on for very long, though, because only a few minutes later, the temperature of the flask quickly spiked from the 230°C that it was at all the way up to 380°C, which I
Yeah.
really didn't like. I don't like that. It just went up 150 degrees in like
That means
30
you're
seconds.
out of reaction
So,
to cool the
I think
process
it's done.
down. So
I think there's like nothing left in the flask. I'm not heating it anymore. I'm done. So
sensible.
I just went ahead and ended it here, and I turned off the heating. I then went over to the other flask, and I got rid of the dish of cold water, and what I immediately noticed was that it had actually separated into two distinct layers.
Well, that's actually
This
kind of
told
interesting.
me that there was for sure a whole bunch of nasty crap in there, and I was pretty certain that the black layer on top
No, what tipped you off to the nasty crap, Nile? The fact that your acetic acid is brown and it's normally a clear liquid?
was mostly the carcinogenic benzene. Moving on, though, I then popped off the flask, and the moment that I took it out of the fume hood, I was hit by the smell of it,
Oh, yeah.
which can only be described as a mixture of burnt plastic and gasoline, and it pretty much gave me an
This
instant
burnt
headache.
plastic smells funny.
In my mind, this really reinforced the obvious fact that there was a whole bunch of nasty junk in there, because pure acetic acid should have smelled much more like really strong vinegar,
And
and
be
I was
clear.
definitely going to have to clean it up.
And be clear.
So
That's
that was
maybe the
exactly what I
first
started
indicator.
doing, where the first step was to pour it all
Alright,
into the biggest
separatory funnel
that I
time.
owned, and to let it sit there for a bit for it to separate back into two layers. This then happened extremely slowly, and even several minutes later, it was really hard to see any difference, but I felt that it was good enough, and I started draining everything into a large beaker.
Okay. I guess to explain what the what's going on here, this one might actually take a while, so I'll throw on the music to kind of supplement the stream a little bit. Just turn that way down. There we go. That should work. Okay. So, a separatory funnel is... Let me erase all this or make the layer invisible. There we go. So a separatory funnel looks like this. You can excuse my crude drawing. It's good enough. And then there's like a little bit of a vein and a stopper here. Yeah, use that. Represent a bar that way. Okay. So what you use a separatory funnel for is that you would pour in whatever your mixture is, and because of like gravity and density, it should separate out into two distinct layers. I need to stop trying to correct the shape of this. If you have two solvents that don't mix very well, like how oil and water don't mix very well, they will separate out based on their density. And so you can end up having usually a water and aqueous layer down here, which I'll represent like this, AQ with H2O in there. And then another layer, let's just say, I don't know, solvent. Or no, probably an organic layer, because these kinds of organic chemicals, things like benzene and benzene, toluene, paint stripper type chemicals are not going to mix with the water very well. So you're going to have the organic stuff on top, the water stuff on the bottom, and this is good because the organic stuff will dissolve certain things pretty well that won't dissolve well in the water layer, and vice versa. Just like how table salt will dissolve well in the water layer because it is an ionic compound, and ionic compounds like to dissolve in water due to the polarity of water and the distribution of electric charge, but let's not go down another tangent that we won't recover from. The organic layer, on the other hand, will dissolve very non-polar things like fats or like little plastic residues or other small organic molecules that don't have those polar groups on them. So, you know, once you use gravity and let things settle, you should be able to like pour off, in this instance, the water layer by opening the valve down here, which is referred to as a stopcock. And, you know, let it pour out the bottom, collect that, and all is good. You have your liquid layer. And then you could, you know, either harvest your organic layer, throw it in the waste, or do whatever you want with it. Probably not pour it into the ocean, though. That will kill the fish. And, you know, sometimes things don't separate out very well. That's when we would say that something has formed an emulsion. You might know emulsions better from things like, you know, mayonnaise. Mayonnaise is an emulsion of fats, of water and oils and other, you know, compounds in between there. And that just results because there are certain molecules that are good at bridging the gap between the organic layer and the aqueous layer. So what probably happened to his solution here is that because there's just so much gunk and junk and other crap that's kind of like somewhat soluble in both the organic and water layers, it didn't separate very well. And a typical way to actually make it separate better is to actually add salts like sodium chloride into your water, because as I kind of mentioned before, sodium chloride really wants to dissolve in the water because it's so ionic, and that will in turn increase the polarity of the water and make it repel the organic stuff more. So I'm interested to see his cleanup. If he ends up adding brine afterwards, be like, a classic mistake. You could have done that earlier to get a much better yield and much easier cleanup, but I don't know. I just said, sorry, tangent over. I wanted to talk about separation and just what this piece of glassware is. It's a very common chemistry technique, so I wasn't sure if he was going to actually go over it or not. Hopefully he doesn't, so that way I didn't just, you know, meander all your time.
That it was good enough, and I started draining everything into a large beaker. At the same time, I also looked very closely at the separatory funnel to track where that upper layer of nasty black crap was.
Yeah, kind of
and when it
all...
eventually got to the bottom of the funnel,
decent
I
separation.
closed the valve. I then quickly got rid of all of this mystery oily junk, and now, when I looked over at the stuff in the beaker, I felt that it was already looking a bit cleaner, which was good. It was still super dirty, though, and I would, of course, have to do a bit more work, except before doing that, I wanted to do a quick test. More specifically, I wanted to do a pH test, because up until now, I hadn't really done anything to confirm that there was actually any acetic acid in here.
Fair
I'd
enough.
basically been going on pure hope.
You're probably gonna have
So
a
with
lot of
that being
acetic
said,
acid
I
in
just went
the
ahead and tested
organic
it,
crap layer, though,
and I was
because
kind
acetic
of
acid is pretty
worried
good
that it
at
would
dissolving
show
in
that there
either.
wasn't actually any acid in here,
Oh no,
except that
bright
thankfully
red,
wasn't the case,
super
and the
acidic.
paper had instantly turned a reddish pink. This told me that it was quite acidic, and that there was probably a decent amount of acetic acid in there, which meant that I was no longer just going on hope, and I could now move on with the rest of the cleaning. To do this, I also just kind of made up a procedure that I figured would work, and to get started, I dropped in a stir bar. Then into this, I added 400 mils of distilled water, which caused it to immediately turn white, and this was
Interesting.
because a bunch of oily stuff that couldn't mix with the water was separating out. All of the acetic
I think that's kind of funny that it ends up turning white again. It's very much like the glue, you know, how it's back to its original state.
acid, though, should have easily dissolved into the water, and after letting it sit for a few minutes, I started adding some regular baking soda.
Yeah,
This caused it to
yeah,
immediately
that
fizz
makes
and
sense.
bubble as it reacted with the acid in there, which theoretically should have only been acetic acid, and it was turning it into sodium acetate.
Which is even
As a
more
side
water
product, it was
soluble.
also producing a lot of water and CO2
It'll
gas,
help separate it
and
from
my
all the
goal
oily
here
tar
was to
stuff. The
basically
tar
just
will let
keep
go.
adding it until it stopped reacting. This is because at that point, all of the acetic acid would be converted to sodium acetate, and I figured that this would go relatively quickly. However, this process turned out to be really slow
Eh.
because every time that I added it, the bubbling took a really long time to settle down, and it was only an hour and nearly 1 kilo of baking soda later
Holy shit.
when it suddenly stopped reacting.
Well, I guess he does have what, like almost a liter of liquid in there. That is a lot of acetic acid to have to neutralize if that's mostly acetic acid. Also, I can completely agree with the sentiment of, oh my god, how much baking soda is this going to take? Because I have done this kind of neutralization at home multiple times. It always takes like deceptively long for some reason. Like you think you're adding a ton of solid. It's actually not all that much because of how light and powdery it is.
The moment that I saw this, though, I knew that I was finally able to move on from this surprisingly long and tedious step, and what I had to do next was turn on the hot plate. So that was what I did, and the goal now was to slowly heat it up
Hmm.
and to boil off any volatile organic junk,
Huh?
like the benzene, and then to get rid of any water.
Wouldn't
The
you
key here,
just
though, was that all of the normally
what?
volatile acetic acid was now protected by being in its sodium form, and in theory, once all of this other stuff was gone,
But
I should be left with just solid sodium acetate.
but why would
So,
that's okay. That's like all right, let's see how it works. That's like a rough theory to work off of though, cuz
I
I
just
guarantee
kept
you there's
heating
going to
it,
just be like
and it was
tar
really
left in
satisfying
there,
to
and that
see all
tar
of
is
the
not
vapors coming
volatile.
off,
It's going to stay
knowing
in the
that a lot
beaker.
of it was benzene and other miscellaneous nasty volatiles. This also went on for a pretty long time,
It would have been
where
better
the
just to wash it
temperature
again.
just slowly
Use a
rose,
solvent. Wash
and it
it
was
out
only
again.
about an hour and a half later, when all of the volatile crap was gone, and the temperature eventually got to 100°C. At this point, it was probably mostly just water coming off,
Boil off the
with
water,
maybe
huh?
some residual oil and other trash, and now I just had to wait for all of the water to disappear. The
This
only tricky
is
part was that I had no
uh
idea how long this would take, and I was also pretty afraid of accidentally burning all of the sodium acetate,
okay.
which only got more and more likely
Can't
as the water
It's really
content
hard to burn a
decreased.
salt, but
So,
sure.
to make sure that didn't happen, I ended up just staring at it, and for another hour,
Like
it
watching
really
paint
didn't
dry.
look like very much was happening until it suddenly started looking like it was getting a bit thicker. Then, over the next 30 seconds, it got thick enough that the stirring had completely stopped working, and not even a minute after that, the entire thing had completely solidified.
Okay, that does look
When I saw
cool.
this, I immediately turned off the hot plate
It's got
to
like
prevent it from burning,
you could see
and I
all like
was
the little
honestly
holes where
really
gas are
impressed
escaping. It's like
with
kind of like
how much
coral
sodium
almost.
acetate there seemed to be. I mean, There was a pretty decent chance that I'd added way too much sodium bicarbonate, and that was a lot of what was here, but I was still pretty happy with it. At this point, though, it was getting pretty late, so I decided to just leave it overnight and to let it cool down. Then, when I came back to it in the morning, I
Unfortunately, the
was ready
overnight
to
elves
continue
got
with
to
the
it, and you
cleanup,
never saw it
and
again.
the first thing that I did was add a bunch of acetone. This is because this would easily be able to dissolve most of the impurities that were still there, as well as residual water, except it shouldn't at all be able to dissolve the sodium acetate.
Hey Nigel, why didn't you just add the acetone first? Because like the salt wouldn't have been soluble in the acetone. Like you could have washed the organic crap out first and then just boiled down the water solution. Okay.
So, in theory, this should allow me to basically wash the sodium acetate, and over the next few minutes, I just mixed it around as best I could, and I occasionally added some more acetone. During this time, the acetone also
Very
slowly got darker and
crumbly.
darker, which I
Graham
was very
crackery.
happy to see, and this told me that it was definitely pulling out a bunch of crap.
Yes, it is.
When I eventually felt that it was done, though, it had become a really dark red color, and
Yes,
all I had to
exactly,
do
Grim.
next was dump it into another beaker. I also did my best to not lose any of the sodium acetate, and when I brought it back, I felt that the powder was already looking a lot better.
Yeah,
However, it was still quite yellow, which
definitely
I
still
really
not
didn't
white.
like, so I decided
Not a
to
white
just keep
free-flowing
washing it
powder.
with acetone until I felt that it was super clean. After a few washings, I
Oh, hey,
also
look at that.
started heating the acetone
It's actually
and
starting to look
bringing
clear
it to a
now.
boil just to really strip off any crap. And each time I thought that it was really satisfying to dump off all of the dark liquid.
Never mind the
I then
the
did
the
what felt
pea
like a
spot that's
million
forming
more
on the rug.
washings, where eventually the hot acetone was only turning yellow and the powder was looking way better, and I felt that this was good enough. So I quickly got rid of the acetone and I did my best to transfer everything to a large dish.
All right, still kind of an
I then
off-white
just let it
powder.
sit there for a day or so with occasional stirring to get rid of any residual acetone. And when the smell of acetone
It does
was
kind of look like
eventually
pea, Grim.
completely
You're very
gone,
right.
I put the
Although
entire
this is
dish in my
pea full
vacuum
of
over. I did
gallstones
this
and
just to
urea
really make
crystals.
sure that it was absolutely dry, and when I eventually felt that it was looking good, a few days later, I took it out, and what I had now was some nice and crunchy powder.
Grunchy.
More specifically, though, this was a bunch of completely dry sodium acetate,
Now it looks
where
like kitty
pretty much
litter.
all of that original nastiness had been removed, and so far, I was very happy with how things were going. This was especially because now I was really close to being done, where the only thing that I
Probably
still had
still
to
could have
do
purified
was
that a little bit
convert
better.
all of this sodium acetate back into some pure
It still looked
and
pretty yellow.
water-free acetic acid. As far as I could tell, this was also relatively easy, and all I had to do was transfer my dry sodium acetate powder to a large flask. I then put together almost the same setup that I used for the glue, except this time, above the flask, I included a separatory funnel that I'd filled with an insane amount of concentrated sulfuric acid.
Yeah,
If
makes
this
sense.
ended up tipping over or something,
Also, hey, look, it's that sulfuric acid I said that probably could have been helpful in the beginning. It's almost like this process calls for sulfuric acid no matter what.
it would have been an absolutely horrible disaster, especially if it splashed on me, and I honestly felt pretty uneasy suspending over 3 pounds of this acid in the air. But with that being said, when I
Yeah,
felt
it's
that I
not
was
good to have
ready,
above eye
I
level
just
there.
unleashed the sulfuric acid, and it started bubbling the moment that it touched the sodium acetate. This told me that it was definitely reacting, where in theory, it should have been turning it all back into pure acetic
Yep,
acid
simple
and
protonation,
forming sodium sulfate as a side
exchange of
product.
ions.
It was also generating a lot
Also,
of
ew,
heat, which was
brown.
enough to boil off the acetic
See, I
acid
told you it wasn't
and to
pure.
fill the flask with a bunch of white vapor. This
It
white
shouldn't be
vapor
turning
was
brown
then
if there's
traveling
if
out
it's
of the
only a salt in
flask
there.
and down the condenser column and filling the receiving flask. Then after that, it wasn't long before I saw my first drop coming over, and at least theoretically, this should have been some nice and pure acetic acid.
You've
Also, because
you've
I'd
created
put
a
so much
cloud.
effort into
Oh
drying the
God.
sodium acetate, and because I was using sulfuric acid, which really liked to suck up moisture, all of this acetic acid should have been completely water free.
I mean,
But with
assuming you're
that
not
being
just
said, this
getting
process
fumes
was pretty
over.
simple, and I
Yeah.
basically just had to
Look
keep.
at that. You can actually see. So this is kind of what people mean sometimes when when they say something is like chemically cooked as opposed to like cooked with heat, because like it's turning into char just like it would with like heat as well. Sulfuric acid is a really really good dehydrating agent. Like if we go back to that original drawing I had, it's like it's really good at dehydrating things because it's so good at donating hydrogens to like um rogue oxygens, or not rogue oxygens, but like just oxygens on various groups on molecules, kind of like this one. If that was a OH group and it got a proton added to it, it'd be a water group. And so water, leaving it, dehydrate. You see where I'm going with this. And it's just like, oh, well, it probably would have also worked to cleave off the acetate groups at the beginning. And like, if you're dehydrating something as well, usually in organic, you'll just leave a big carbon mess left behind, like this big chain of carbons would be. So like that's why it's kind of turning into this, yeah, charcoal chocolate crumb cake. That's hard to say for 4 times fast.
Adding the acid. Then, when I was eventually done adding it, all I had to do was swap the funnel for a thermometer and turn on the heating, and go until I stopped collecting any acetic acid.
Hmm.
However, I had no idea how long this was going to take, and just like many of the other
It
reactions that I'd done so
kind of
far,
looks like there's some
it ended up
unreacted
feeling like it was
material
going
there
on forever.
too.
At some point, I also noticed that the stuff I was collecting was slowly getting more and more yellow, meaning that some sort of impurity was somehow making it over, which was kind of concerning.
I wonder if it's one of the many
But either
tars that
way,
you left
after a
behind.
couple hours, I basically stopped collecting anything, so I turned off the heating, and left in the flask was just a nasty mixture of sodium sulfate and carbonized junk, along with some extra sulfuric acid. This was also trash that I didn't need
Yuck.
anymore, and
Very
the
yuck.
only thing that mattered was what was in the other flask, which, according to my plan, was supposed to be super pure and absolutely water free acetic acid.
Well,
Unfortunately, though, nothing ever goes to plan, and the fact that it was yellow told me that it for sure wasn't pure, and that I was going to have to do a bit more work.
I think just
This
redistill it.
wasn't
It
ideal, and
does
it
take work,
kind of
but it
felt
should
that
be
at
pretty
this
easy.
point, this cleanup was never ending. But on the bright side, I felt that this would be pretty easy, and that I would just have to quickly distill it again. Except, long story short,
Uh-oh.
it was not easy or quick.
Uh-oh.
This was because it turned out that not only was it dirty, it actually wasn't even close to being water free, and there was apparently an insane amount of water in it, which I think came from adding way too much sodium bicarbonate.
What? I I guess there could have been excess of sodium bicarbonate in there that would release water if it was reacted with, but I would think that the water in there is just because of the fact that like, you did use a sulfuric acid solution. That does in fact contain water. It's not going to hold on to it perfectly, especially at a reduced pressure and high temperature. It's gonna come over slightly. It it just kind of tracks that way.
So, unfortunately, even after distilling it, it was still full of water, and it didn't seem like just doing the same distillation again was gonna work. I really needed it to be perfectly dry, though, which meant that I was gonna have to somehow fix this
Come on,
problem.
Nigel, break out the
And
molecular
thankfully,
sieves.
after spending a long time searching online, I ended up finding something on the Science Madness Chemistry forum that seemed like it would work.
You don't
So I
need to
decided to just go for it,
dilute with the.
and the first
Alright,
step
whatever.
was to take all of my acetic acid
I think the
and to add a
magnesium
bunch of
sulfate
solvent
would
called
work.
dichloromethane, or DCM for short. Then on top of this,
Ah,
I
yes,
added some magnesium
dichloromethane, the thing
sulfate
that is
drying
making
agent,
my life
which
hell
would
at
pull out a
work
bunch of residual
because
water,
of
and
EPA
after letting it stir for
regulations.
a while, I filtered it all directly into a large flask. By doing this, I was able to quickly get rid of all of the magnesium sulfate, and eventually I was left with a nice and clear solution, which should
Right,
have
but
already been a lot drier.
you do now
With that
have
being
the
said, though, I
dichloromethane to
then set it up
distill.
for yet another
You
distillation,
could have
except this
probably
time
just
I
added the
included this
salt.
really long piece
Salt,
of
the
glass,
magnesium sulfate would
which is
dry up the
something
water,
called
it
a
would take it up.
fractionating column. This is because it would allow me to do a fractional distillation where I would get a much better separation of water and acetic acid, and I just went ahead and cranked up the heating.
I guess to explain slightly. So by fractional distillation, it's kind of a it's a little bit of an archaic term. Back in the day, to do multiple distillations in a row, you would just be using smooth-sided glassware that yeah, kind of looks like this cooling tube in the middle, smooth like that. It would just be like smooth glassware that your vapors would go up. And the principle is that vapors only condense on the edges of glassware because I mean you need a solid for the liquid to kind of for the gas to kind of nucleate and form a liquid and drop back down. So in ye olden days, people would just kind of hook up multiple smooth glass distillation setups in sequence from another. So it's like you would have kind of this round bottom, this a smooth version of this glass piece, and this cooling column kind of repeat ad nauseum. And doing more and more of that allows you to get a better separation of your um, distillate that you're trying to collect and the other junk that you're not trying to collect for just various reasons of concentration and how thermodynamics works. Again, another rabbit hole for another day. But in whatever year when glass blowing techniques got really good, it was kind of found out that like, well, if you just increase the surface area of your original distillation column, then that's going to act as if it is multiple fractions, multiple simple columns together. So a fractional distillation in this sense just means that you have a column with a lot more surface area than a typical smooth piece of glassware. And so it ends up being more efficient, and you only have to do one distillation instead of effectively many.
Water and acetic acid, and I just went ahead and cranked up the heating. The idea here was to then first distill off all of the DCM, which would come over at around 40°C, but the important part was that it wouldn't distill off alone, and it was supposed to pull any remaining water along with it. This was also exactly what seemed to be happening, because all of the DCM that was coming over was looking cloudy, which told me that it was full of water. What was then a very good
All right.
sign was that as I kept
That
collecting
sucks.
it, the drops slowly cleared up, meaning that there was less and less water, and when all of the DCM was eventually gone, the temperature started rising. I then
And
waited for it
shut
to
it
get
off.
to exactly 118°C, which was the boiling point of acetic acid, and when it eventually got there, I waited about 30 seconds before quickly swapping the flasks.
Oh, that works too. You'll
At
leave
this
any
point,
like
everything
high
that I was
boiling point crap
collecting
behind.
should have been absolutely pure and completely dry acetic acid, and something that I noticed was that, unlike all of the other distillations, there wasn't any fogging or smoke. But either way,
Hooray!
I then continued collecting
No
everything
steam
that came
distillation is
over,
occurring.
and the moment that the temperature started dropping below 118°C, I ended the distillation. I then took everything that I got, and I carefully poured it all into a nice bottle, and what I had now should have been 100% pure acetic acid.
All right,
The
boys,
only
we've made
sad part was
concentrated
that the
vinegar.
amount that I ended up
Let's
with
go.
was only around 100 mils,
Wait, weren't we
which
making
was
ethanol?
less than half of what I started with before trying to dry it.
That's right. We're only halfway
However, this
through.
still should have been more than enough, and I was extremely happy that I was finally done this part and that I had some theoretically pure acid. To actually know for sure that this was acetic acid, though, I was going to have to do some tests,
Oh,
and I
please God,
decided
don't
to
taste
start
it.
with the easiest one, which was to just see if it smelled like super strong
Okay,
vinegar.
good.
Okay, that's definitely acetic acid.
Yeah, it's a
So,
characteristic
at least
sharp
from this
smell.
quick little acid smelling experience, whoa, I was almost certain that this was pure acetic acid, but to fully prove it, I was of course going to have to do some real tests. So, the first thing that I did on it was an FTIR, which
Ooh.
I then followed up with an HNMR, and I was very happy to see that both of these together fully confirmed that this was for sure acetic acid and that it was quite pure.
So, real quickly, just what these two do, so that way we don't get stuck in a rabbit hole for too long. FTIR stands for Fourier Transform Infrared Spectroscopy. I guess the spectroscopy part's a separate word, but anyways, so it stands for that, and that basically involves um I guess I should draw a diagram, a small diagram for this. So that would involve basically having what is called an anvil, typically one that is tipped in diamond, um, pressed against your liquid sample of choice. So I'll just draw that sample. And then it is going to be sitting on usually a little sapphire window. So I can annotate this a little better. Anvil, sapphire. Shouldn't have drawn it so far away from the arrow, but that's okay. There we go. And what happens is that you'll basically have your infrared light be shot at the sample and through the sapphire window. Just write this as IR. And some of that will touch the sample, and then some of it will return out. In fact, I should draw a dashed line just to show. So, yeah, the IR light will shine into the sample. It'll reflect off of the anvil. And while it's in the sample, some of those infrared light waves will be absorbed. As you can kind of sort of see down here, the x-axis is in wave numbers in the video. That corresponds, you can do calculations to correspond that to wavelength. And so what you're essentially doing is you're shooting multiple different wavelengths of IR light. So something between like say 400, no, not 400, 800 nanometers and 2000 nanometer frequency light, which translates to, no, wait, sorry, that is wavelength. So like something between like 2000 and 800 nanometer light. Your organic sample will absorb some of that light, and the light that is not absorbed, so this light, coming off of it that is not absorbed, that light will be going into, a computer that will basically tell you what wavelengths of light were not absorbed and give you this kind of pattern that you see on the left here. And any of these big valleys or peaks, if you look at it from the opposite direction, is kind of like the light waves that got absorbed by your sample, and that is pretty much a characteristic fingerprint of how that compound likes to absorb that light. The reasons why it likes to absorb certain light waves or light wavelengths rather than others is basically just like at a certain point you shrug and say, as quantum physics, but it just comes down to the structure, what groups it has, and how, for whatever reason, those groups have like different energy gaps and they absorb light at those energy gaps. And so, if you know that you have a pure compound and you can take an FTIR to say, okay, well, that's kind of the fingerprint for that compound. And, if you are, say, like the National Board of Standards, then that becomes the fingerprint, and other people can compare their fingerprint that they get from their FTIR experiments and compare it to the National Board's FTIR experiments. And therefore, they will, be able to confirm that that's their product. On the other hand, so that's as simple as I can probably make FTIR and take only a couple minutes. On the other hand, you have HNMR, which stands for proton NMR, H being the hydrogen atom, and hydrogen without an electron is considered protons, so we often end up calling a lot of hydrogens on molecules protons, even though they're not quite. Don't think about it too hard. Just associate the two in your brain. And so proton nuclear magnetic resonance, which is another light-based absorption technique. This time, instead of infrared light, you're shooting radio waves at your compound, and also doing some other fancy magnetic stuff to cause shifts in magnetic fields and turn that around. But again, to keep things simple, this is a similar experiment where you're looking for your compound to absorb certain frequencies of radio wave light. And based on the frequency of radio wave light, or the wavelength of radio wave light that it absorbs, fancy math happens within the computer, and you'll get peaks that correspond to light being absorbed, and will tell you about the structure of your compound. You'll get peaks that have intensities related to how many symmetrically identical hydrogens are at that location. So you can kind of see in his HNMR, he has one of these OH protons, and he has 3 of these carbon H protons. And the 3 ones on the carbon are all identical because they kind of rotate around this carbon center. You can kind of imagine looking down the barrel of the molecule, where you can also imagine like, oh, there's another carbon behind here, and like then there's the oxygen group, and then there's the other one. Looking down the barrel of that bond, these 3 can freely rotate around the axis, and so those are all the same. You get a peak here at that 2 ppm range that is 3 times taller, or I guess has 3 times the integrated area underneath, versus the 1 proton all the way down here at the OH part. So, and also the like where the peak ends up on the spectrum is related to the structure around it and how electron poor or electron rich it is, but that's again topic for a whole ass textbook to get into. But essentially this is another good and very reliable, very quick fingerprint way that chemists like to do to make sure that they've got their compounds. So with these 2 things, he has a pretty good indication that, yep, these are the 2 compounds he has. Or this is the compound he was looking for.
What I was most happy about, though, was that I could finally move on to the next and final step, where I would get to turn all of this acetic acid into pure ethanol. And again, in theory, there were many ways to do this. The only tough part was that, at least initially, every method that I found...
Oh boy. Oh geez, 2 of those methods involving lithium aluminum hydride. That's a violent chemical. We definitely don't want to be doing that. Lithium aluminum hydride is prone to igniting in air, especially if you end up crushing it a little bit, because it usually comes as these kind of weird melded pellets. Yeah, you don't want to work with that if you possibly can. Hydrogen over catalyst is fine, but it tends to be kind of slow for these carbon-oxygen reductions. Ammonium borohydride and iodine, still difficult to separate from the THF. I wonder why we went... Yeah, no, because it's not very good at reducing carboxylic acid groups. So another challenge, which I think he'll probably explain, is just that like these carboxylic acid groups, these OCOH groups, they tend to be pretty hard to actually reduce down to alcohols. They just... Because usually what you need to have happen is have like an H minus. Let me go back to the drawing board here. An H minus equivalent attack this carbon oxygen bond and then make way, and then eventually the oxygen will leave as water. And you'll be left with like replacing this carbon oxygen double bond with 2 carbon hydrogen bonds, like over here, like on the ethanol. But the difficulty is that, well, if you have this big, let me erase some stuff. you have this big H minus, what it's actually looking to go for first is, well, there's a nice, easy, vulnerable H plus kind of hanging off of that oxygen. So it's just going to go for that instead, and you'll be left with just, you'll be back to having probably sodium acetate. And, well, hey, we were just there like a step ago. So, yeah, we don't want that. So it tends to be kind of notorious to, like, find a reaction that kind of works around that problem. It's possible, but it's not an easy one. Usually there's weird mechanisms that kind of come into play to make that possible. I don't know why I erased it all like that way, but let's see what he chose. I'm curious.
Seemed to have some sort of major downside. After hours of searching, though, I ended up finding this paper,
Foxide,
which described a process that
Foxide.
appeared relatively easy, and it was supposed to have close to a 100% yield. In my mind, this was also by far the most promising method, and it seemed like it was my only real option, and I decided to give it a try.
Okay, so
I just went ahead and jumped right into it, and the first thing that I did was go over to my solvent cabinet, and I pulled out my DMSO. I then started pouring about 200 mils of this solvent into a large flask, and when it was all loaded in, I turned on the stirring. After that, I lowered in a little tube that was attached to my argon tank, and I started shooting in argon to push out all the air. I don't think this was absolutely necessary, but at the same time, this reaction was gonna produce a lot of hydrogen gas, and I was kind of paranoid that it could mix with the air in the flask and potentially explode.
That is a good idea. I recommend that all the time at my job.
The flask was now full of argon, and what I had to do next was
hydrogen,
add the first
oxygen,
main
bad
ingredient,
mixture.
which was a bunch of white powder. This was all something called sodium borohydride, which is a strong reducing agent, and very soon, this was the stuff that would be releasing the hydrogen. Right now, though, it was still relatively tame, and when it was eventually all added, I let it stir for about 10 minutes, just to give it some time to dissolve. Then, when I eventually felt that it was looking good, I went and got the second main ingredient, which was 9.6 grams of my beautiful acetic acid, and I started to slowly add it.
Alright.
This almost immediately caused there to be a bunch of bubbling, along with a pretty clear fizzing sound, and this was because the acetic acid was reacting with the sodium borohydride and releasing some of that hydrogen gas that I mentioned earlier. More importantly, though, it was supposed to be forming an intermediate known as sodium triacetoxy
yes, it does actually do that.
Which right now might not look like anything useful, but it'll be very important in a bit.
I'm interested in how the DMSO kind of comes into play here.
9.6 grams that I was using here.
Usually it's just a nice,
around 10% of the
not
acetic
inert,
acid that
but
I had.
solvent that I wouldn't
And this is because at
react
this
with
point,
this.
I still had absolutely no idea if this reaction actually worked, and I was too scared to risk more than this. But anyway, once I'd added everything, I again had to let it stir for several minutes to make sure that it all fully reacted. While this was happening, though, I had to prepare the next major ingredient, and to do this, I started by adding an addition funnel above the flask.
Oh, this is only a 2 reagent.
I then went and got another chemical called methane sulfonic acid,
and
I added 53.8 grams of this syrupy liquid into the funnel.
Acid. It's been a long time since I thought of that.
I also added another 200 mils of DMSO, which easily mixed with it, except in theory, I probably shouldn't have been adding a solvent to an acid.
Ew.
I mean, in this case, I knew it would be fine, but that can't always be assumed. And for example, if I had done this with sulfuric acid and water, it probably would have boiled and potentially sprayed out of the funnel.
That's true, actually. It does actually matter to for a safety point of view. If you are if you are trying to dilute an acid, it is better to pour the acid into the water, because when you dilute a really concentrated acid, it actually does put off heat, because for thermodynamics reasons, it kind of wants to be diluted. It kind of makes the acid more stable to be at a lower concentration in water. It helps spread out that kind of the protons that so badly want to jump ship off of the acid. And so that produces a lot of heat. If you pour the water into the acid, you might end up creating a very thick and corrosive mixture that will bubble and just spit acid everywhere because the heat is not dissipating very quickly throughout the mixture. And the more the water spreads, kind of the more heat ends up being generated. Whereas if you pour the acid into the water, well, the water is not very, you know, water is water. We know how it works. It's kind of cool. It's not super corrosive. And as the acid spreads, it gets more dilute. And at a certain point, once you get super dilute, you're not really putting off a bunch of heat. So it tends to be good to pour it that way and not the other.
Once it was all mixed, I sealed the top with a stopper, and now I was ready to make some ethanol. So I just went over to the valve on the addition funnel and I very carefully opened it to dropwise add the methane sulfonic acid.
Well, the
And
methane
almost
sulfonic acid is
immediately,
this thing in the
I
corner,
could
by
see
the
that
way,
it
that
was
I circled.
reacting. This was because there were a bunch of very small bubbles that quickly appeared, which was all hydrogen gas,
Hmm.
that was forming as the acid attacked the sodium borohydride. As far as I know, though, this was mostly just a side reaction, and what I actually wanted the acid to
Yeah, show me the
do
main
was
mechanism.
catalyze a reaction between the sodium borohydride and the sodium triacetoxyborohydride that I
Ah.
made earlier.
Oh, so you added an
The
excess of
paper itself,
borohydride.
unfortunately, didn't give any details about this reaction, but what I think is likely is that the sodium borohydride was splitting apart the sodium triacetoxyborohydride and turning it into something called acetaldehyde. This was then
Hmm.
probably getting attacked again by the sodium borohydride, which would be reducing it even further, and hopefully turning it into some amazing ethanol,
Now, why would this methane sulfonic
right?
acid help
And
out with
turning it
this
into some
reaction? Huh. Because it is kind of just another big acid like that. And you think, and I mean, you even would see it, like, it does start reacting with the hydrogens on the sodium borohydride. So, like, that would form hydrogen, and that kind of nullifies the reagent a little bit. Huh. Yeah, I don't know. I'm curious why that actually ends up working. Oh, maybe. Okay, I think it's a bit of a stretch of an idea, but I think maybe what ends up happening is, and I'll try to draw this quickly. Do this. Have that attached to the boron. Just say that there's 3 of these. Boron's going to be minus because there's 3 of these groups. I think that maybe what's happening is that with the methane sulfonic acid is that potentially these electrons on the acetate groups off of the boron are going in, taking the proton off of the acidic proton off of this, which would then result in having the ew, that's a terrible arrow. Which would then result in having this kind of electron deficient group on here, which maybe the I think maybe because like there is like this position available, like this hydride might then be in a good place because it's so close by and would kind of like maybe be a little bit further from this easily accessible hydrogen. This one could just kind of go in right there and then start doing the magic and like actually start cleaving this group off, leaving the OH with the boron, and thus you get that acetaldehyde thing that he was talking about. Like this ends up popping off, electrons go up here, they then come back down. This is a shorthand, goes back over here, these electrons in this bond, and then you end up popping off the acetaldehyde with this hydrogen being this one. I think that might be what's happening. Maybe. You'd have to go and actually do a research paper to prove that, but I think that's a reasonable assumption as to what might be happening.
Something called acetaldehyde. This was then probably getting attacked again by the sodium borohydride, which would be reducing it even further, and hopefully turning it into some amazing ethanol. Overall, I thought that this was all pretty exciting, except what did concern me was that the paper also didn't give any real details about the reaction process itself, and unfortunately,
Yeah, that
even
paper
though it
did
was
look real
still
old.
very early on, it was looking like it was going to be a temperamental one. This is because after barely adding any acid, it was already warming up, and at this
Hell,
point,
yeah. It's gonna
it
be
was
hot.
getting up to around 40°C. It was also looking like it was slowly getting foamier and foamier, which would only get worse as it heated up, and I was definitely going to have to cool it down. So I just quickly added a large dish under the flask, and I filled it with a bunch of water, and this very quickly brought the temperature
Cool it down
down
if you
to
don't want
around
it to
15
go
degrees
crazy. But
Celsius,
going crazy is kind of
which I was
fun.
very happy to see. This is because the crisis seemed to be over, and even though it was still bubbling, it appeared to be much more controlled, and now I figured that I just had to add the rest of the acid. So that was exactly what I did, and what I thought was really interesting was that as I added it,
It's milky.
the reaction seemed to go through a few different phases. For example,
Do
for
tell.
some reason, despite the cooling, it all started getting frothier and frothier again,
Hmm.
except right when I started getting concerned that it might eventually foam out of the flask,
It's probably all the
it all
boric acid
suddenly
that's being
thinned out.
formed. Oh,
This
and
then
then it
made me
just
think that
settles.
I was basically in the clear and that I was past the worst of it, but then it suddenly started thickening way worse than before, and it actually ended up completely freezing. At the same time, it was also
Yeah.
slowly puffing up,
Oh
which was
god.
very concerning, except it again just
Crisis,
suddenly
crisis.
started thinning
Oh no.
out,
That's fine
and it
again.
wasn't long before it completely liquefied.
Huh.
This constant back
Wow.
and forth, though, made it so that I absolutely didn't trust it anymore, and I became constantly
That
worried
is
that at
actually
some
really
point
crazy.
it could just start foaming
I've never seen a reaction go
uncontrollably,
and do that. Usually
except
they
that
are
thankfully
a
never
little bit more
happened.
behaved.
This is because it
Like,
actually
that's
ended up
funky. I
being
like that.
super tame, and when I eventually added the last bit of acid, I was left with a nice and slightly gray solution. At this point, though, the reaction wasn't quite done yet, and I was gonna have to let it stir like this for a bit longer. So while I was waiting, I went and got a beaker, and I added about 180 mils of water. Then after that, I dumped in 20 grams of sodium hydroxide drain cleaner,
Oh, yeah, we
and
do
I
need to
turned on the
neutralize
stirring,
all this
and I
acid that
waited
we've
for it to
made.
fully dissolve. When this eventually happened, I had a nice and clear solution, and at this point, it had been about 15 minutes, so I went back to my reaction, which now should have been done, and I started pouring all of this into it.
Maybe put some
This
ice into
strongly
that bath,
basic
buddy.
solution was then
It's gonna get
quenching the
real hot.
reaction, and it was destroying any sodium borohydride or acid that remained. For whatever reason, it also caused the whole thing to clear up quite a bit,
Yeah.
and I started noticing little drops of something oily appearing on the side of the flask.
Probably
But
condensing out all
moving
the
on,
boric acid
what I
in the
had to do
solution.
next was get all of the ethanol that I hopefully made out of this mixture of chemicals. According to the paper, this was also relatively easy, and apparently, all I had to do was some more distillations. So I just immediately got started with that by
Yay, more
getting rid of the water
distillation, more
dish,
hours of your life
and then I
spent,
quickly
more
added a
energy pumped right
stopper,
into a
a
beaker.
fractional column, and another stopper, and I put
Distillations are a
together
pain in the
pretty much the
ass.
same setup that I
They're not even
just did
hard,
for
they
the
just take
acetic acid.
forever. They're so
I then
energy
cranked up the
consumptive.
heating, and it wasn't long before the first stuff started coming
It's
over
kind of
at
literally
around
also all about
35°C,
watching a pot
which I
boil.
assumed was
So
that
like
oily junk that I saw
that
before.
that doesn't take
More
forever.
specifically, though, I was pretty sure that this was all something called dimethyl sulfide, which was supposed to be a major side product in this reaction.
It's true.
The
Probably
only
would
unfortunate part
reduce
was that it
down
was
the
also
sulfuric
supposed to
acid
smell
or the
absolutely
DMSO.
horrible, but at such a low boiling point, I figured that it would be removed pretty easily. With that being said, I then just kept collecting it until the temperature suddenly started spiking, and when it eventually got to about 80°C, I swapped the flask for a fresh one. This was because at this point, if there were any ethanol in there, this was when it would start coming over.
Hmm.
The only tricky part was that it wasn't going to be coming over as pure ethanol, and it would instead be a combination of ethanol and water.
Yep.
This in turn meant that to get all of the ethanol,
If you've ever wondered why you can't purchase 100% ethanol at the store, it's because when distilleries distill ethanol, it can only come over as a vapor of at most 96% ethanol and 4% water. It is just That's a result of just kind of thermodynamics saying, hey, having a little bit of entropy in this mixture by having 4% water is like the perfect balance of the universe in this, bro. Um so like that 4% water is not going to boil away. It is happily stuck to the ethanol at that point. To get to absolutely pure ethanol, you have to use drying agents afterwards, magnesium sulfates or molecular sieves that are specifically only large enough to capture water, but not ethanol.
I was also going to have to collect all of the water that was in there, which was around 200 mils, and over the next couple hours, the volume in the flask slowly rose. At the same time, the amount in the main flask slowly went down, and with less and less water, a bunch of solid stuff started forming, and this was all just junk from the reaction that was being left behind.
Yeah, junk.
Going back to the other flask, though, it did eventually get to the point that it was around 200 milliliters, and right when this happened, I turned off the heating. I then quickly popped off the flask, and what I had now was, at least in theory, around 5% ethanol,
Pretty
which I thought
nice.
was pretty exciting. However, just by looking at it and
It does
seeing
have some
all of the
chunkies in
little
there,
oil
though.
drops
A little
that
bit of
were still
backwash.
somehow floating around, it was obvious that I was going to have to clean it a bit more. So I decided to do another distillation,
That's a
except this
tall
time I
fucking
would use
column,
a
dude.
much more efficient fractional column, which would hopefully give me a better separation
That's
of
got
ethanol
many
and water.
fractions within it.
I then just went ahead and cranked up the heating, and I basically did the same thing as before, where I rejected everything that came over below 80°C. The major difference this time, though, was that I wasn't going to be collecting all the water, and I was actually going to try to leave behind as much as possible by pulling off the flask the moment that the temperature got to 100°C. So that was exactly what I did,
All
and then I
right.
very carefully transferred everything that I got to a little vial, and at this point, I was pretty happy with how things were going. This was because, assuming that the reaction had worked, what I had now should have been relatively clean ethanol. To fully confirm this,
Mission
though, I
success.
was
All
going to
right.
have to run it through my NMR, so that was what
Do
I
all the
did.
spectroscopy
And
again.
well, it told me that it wasn't super pure, but it was for sure ethanol. To get its concentration, I then
It
did
also had
another
water in there
test
too.
by
Yeah.
putting a few drops of the ethanol onto something known as a refractometer, and when I looked into it, it told me that it was at least 80%,
Hmm.
which was actually better than I expected.
So that's a device that's not very common in the actual lab, but it is common in like, alcohol distilleries, and it's just useful to be able to take a quick look at your sample, and based on how the light refracts off of your sample, it'll bounce off at different angles depending on how concentrated it is. So, hey, you at least got 80% ethanol. That's pretty good.
The only unfortunate part was that when I went to do the very necessary smell test, I was not very impressed. This is because instead of getting a nice and clean ethanol smell, it was almost unbearably sulfury
Ew.
with a horrible rotten cabbage stench. I also almost immediately knew that this was all coming from residual
That's
dimethyl
rotten
sulfide,
cabbage
which
stems.
was
That's real
somehow
Polish
able to
ethanol.
make it through the distillations, and I was honestly getting a bit worried that this might end up being a problem. At the same time, though, I felt that it was probably fine and that it could be easily removed with some more distilling, and instead, I decided to focus on how well this reaction had worked. I mean, the yield wasn't even close to the 93% in the paper, and it was more like 48% because
Oh.
they didn't fully isolate it like I did. But overall, I still really liked the process, and I liked that it was relatively simple and easy. So I decided to just keep going with it and to use it to convert the rest of the acetic acid that still remained,
Oh, that's
which
right.
was
He only did a
about
small
89
amount.
milliliters. The only
Oh
problem
boy.
with this plan, though, was that if I were to just repeat exactly what I did, I would have had to do it 10 more times, which sounded absolutely horrible.
You would
This
need
is especially
much,
because it would
much
have
bigger
taken at least
glassware.
10
Do it
more
all in
days of
one.
work, and to avoid this, I ended up just scaling every.
Oh my god. Look at the size of that 3-neck flask. That's gotta be like a 5-liter glassware, or maybe even 20. No, probably not 20. That's crazy. That's like a 5-liter thing. That is some specialty glassware at that point. Like regular size 3-necks, pretty common. It's a little bit pricey. This I can imagine is probably several $100s on its own. This is some crazy shit.
Everything up by buying a brand new 5-liter flask. I then did the
5-liter.
exact
Yep.
same reaction as
Am I good or what? Do I know my chemistry or what? I knew that shit was 5 liters.
before, except with way more of everything, and the only real difference this time was that cooling it was a bit more difficult. When the reaction was eventually done, it also looked really interesting,
Ooh,
and
it's
it was
galaxy
kind
light.
of mesmerizing to look at, and it was a bit sad when I had to quench it
Aw.
by dumping in the solution of sodium hydroxide. But either way, after this, I then did the distillation to get out all of the water, except this
Ooh,
time,
it turns
instead
some
of
weird colors.
immediately doing a second distillation, I poured it all into a different flask. This was because, even on this ridiculously large scale, I was only able to process half of the acetic acid, and
Huh.
before moving on,
I
I
had to
was
do it
gonna have to
twice.
convert the other half that still remained. So that was exactly what I did. And when I was
One more
eventually done the
time.
reaction and distillation, I took everything that I got and I combined it with the stuff from the first half. This way, I would be able to distill both of them at the same time, which was just a bit more efficient than doing them separately. And when I was done a couple hours later, I had what looked like a pretty decent amount of 80% ethanol.
Yeah.
I then took everything that I got and I carefully poured it all into a fresh bottle, and in total, it ended up being just over 80 milliliters.
And
I then brought back the roughly
oh, how much?
6 mils that I got
6
from the
mils.
first run, which together with this was now nearly 90 mils, and this was way more than I ever expected to get, and I was feeling pretty happy about it.
1 gallon of glue. If you purchase 1 gallon of glue, you can then distill your own alcohol and get about from 1 gallon of glue down to 90 milliliters of alcohol. The ATF hates this one weird trick.
The
Become a
only
moonshiner
problem was
today.
that right now it was all still nowhere near drinkable because it all smelled terrible and
Yeah.
it likely tasted like horribly rotten cabbage.
You say likely tasted. Not NileRed, I know you. You absolutely just tasted a little bit of it.
As I
Had that
mentioned
visceral
earlier,
reaction.
though, I felt that this would be relatively easy to get rid of and that I would just have to
Oh.
combine everything and do one final distillation.
This one's actually kind of
However,
interesting.
just like everything else in this project, that absolutely wasn't the case. And
Oh,
even though I
darn.
included a bunch of copper, which was supposed to help remove sulfur compounds, the final result that I got was still far from good. It
Still stinky,
smells
huh?
pretty bad. I mean, it was definitely better, but it was still nowhere near drinkable. And to get rid of this stubborn crap, it was looking like I was just gonna have to keep distilling it over and over.
Now, what would help is if he would actually, well, I don't know. When he did his NMR, it kind of looked like it was mostly just water in there, but potentially he could maybe suss out what the other compound could be. using those other methods that he demonstrated earlier. Maybe could help him identify what other garbage is in there, but we'll see what he does.
So that was exactly what I did.
Clean up,
And
Niall.
what I did
You're
as
almost done.
well was filter it each time through a mixture of activated charcoal and ion exchange resin, which was basically just a deconstructed Brita water filter, and I think it helped. Overall, though, not only did this whole process turn out to be really time consuming and tedious, it was also not very efficient. This was because to make any significant improvement, I found that I had to sacrifice quite a bit of the initial stuff that came over at ADC.
That
This
sucks.
in turn meant that I lost more and more with every distillation, where by the fourth one, I barely had any left. However, on the bright side, everything that I was collecting now was coming over in the very narrow range of 80 to 81C, which told me that it was quite pure. There was also a very good chance that I had finally gotten rid of that horrible smell, and that all of this stuff here was actually drinkable, which I thought was pretty exciting.
Come on, we're hoping for
It was
potent
then only
potables.
5 minutes later when I was getting really close to being done, except what I had collected at this point was honestly a really sad amount of liquid. I mean, compared to what I'd started with, this was basically nothing, and in hindsight, I really should have avoided any method involving sulfur. On the bright side, though, at least from what I could
I
tell,
mean, hey, at
it
least you
was
didn't follow a
looking like
method that
I'd
would
somewhat managed to
explode
salvage
in your
things,
face,
and at this
like
point,
lithium
it
aluminum
was done,
hydride.
so I swapped out the vial. Now, all that there was left to do was to see how it smelled, and I was honestly kind of nervous and worried that it would be terrible, and that I would have to keep distilling it until I basically had nothing.
That's perfect.
Except that thankfully wasn't the case. I mean, there was still a very slight hint of something else, but other than that, it basically smelled like pure ethanol, and when I ran the NMR, it was clearly way better. More
Well, take it.
specifically, that massive impurity that was here was now just an extremely small bump, and when I compared it to an NMR of some ethanol that I bought at the store, it basically looked the same. I then tested the concentration using the refractometer, which told me that it was about 68%, and it was surprising to see that it was somehow lower than before.
Yeah, it is a little weird.
With all that being said, though, I was
But-
now finally done, and after what was probably way too much effort, it was looking like I had successfully turned a gallon of children's glue into some drinkable alcohol.
All right, so you're gonna make a
Finally did it.
cocktail out of it?
What a sad amount.
At this point, there was also, of course, only one thing left to do, which was to taste it, and to see if all of this effort was worth it. So, that was what I had to do next, except as a quick warning, I should be clear that tasting anything that I make is always at my own risk, and even if it seems fine based on the NMR and other tests, there could always be something toxic or horrible still in there.
Yep.
But with that warning aside,
Don't drink your own
it
chemicals,
was finally
kids.
time to see how it
Trust the
was.
factories to
and
make
I
the
was
food
honestly
chemicals,
feeling a bit nervous.
not yourself.
I just have to, I guess I just have to go ahead and try it. And I hope I'm not poisoning myself.
Yeah, 15 to 20 years, you'll figure that out.
Yeah, okay. I'll just taste it. That's not good.
It's not good.
I mean,
Ruh-roh.
there's the obvious fact that it's almost 70% ethanol, so it just burns, but it definitely has a characteristic flavor. And when I think a bit more about it,
Glue
maybe
flavor.
definitely some sort of some sort of volatile hydrocarbon, like gasoline or something. Definitely has.
We're drinking gasoline in here
it has
tonight,
It
boys.
has a chemical flavor to it. I don't know how else to describe it. Overall, though,
Unleaded
is it
variety.
horrible? No, I think it's
It's
I
just a
think it's
little bit of
totally drinkable
gasoline. Just a
if
little
you
bit.
have nothing else. I mean, assuming it doesn't have some poison in it that kills you, but besides that risk, it's kind of fine. So, in the end, it unfortunately wasn't the amazing alcohol that I was hoping for, but at the same time, I think that it was probably as good as it could have been. I also think that the weird chemical gasoline flavor makes it really unique, and maybe I'm just lying to myself, but I kind of feel like it's growing on me.
Yeah, that's a way to
Overall,
spin it.
though, I'm really happy with how my glue alcohol turned out, and what I think is nice is that I'm now officially building a little alcohol collection, and I can place this next to my toilet paper moonshine that I made
Uh-oh,
years
he has a
ago.
third spot.
I've
He's gonna make
also already
alcohol
set it
another
up
way.
for there to be a third spot here, which is reserved for what is probably going to be my final project in this series, where I try to turn air into alcohol. This is actually a project that I mentioned over a year ago, and I just wanted to take a second to say that this whole
Ew.
time I have been working on it, and I'm hoping to finish it very soon. I should also say that the same goes to all of the other huge projects that I've mentioned over the years, like making magnets from scratch, graphene aerogel, carbon nanotubes, liquid helium, and tungsten cubes. In fact, although I haven't been posting much, I've actually been working on over 20 projects at the same time and spending pretty much all of my
What the
waking
hell?
hours on
Like an
them.
acorn
And at
in
this point,
solution.
my brain's getting close to being overloaded with information.
I
Despite my
bet.
brain being fried, though, I've still been able to keep up with the latest news.
All right, we're getting into the sponsor segment. But anyways, yes, that was turning glue into ethanol. That was, I don't know, that was kind of a fun video. I think there may be concepts I've enjoyed a little bit more, but overall, it's interesting because I've never considered the possibility of turning a plastic in glue and turning that into drinkable ethanol. And, I was skeptical going in first about how, like, wow, this is kind of just lowering in complexity. Why is he doing this? And it's like, this kind of makes sense. It's almost like trying to grab groups off of, like, just grabbing those acetate groups off of the plastic as if you're grabbing fruits off of a shelf at the supermarket and then turning those fruits into fruit juice. It makes total sense once you actually see the molecule, what he's doing with. Criticisms, of course. I think that he probably could have saved himself a whole lot of headache and got a much better yield if he just would have went straight for the kill and just used sulfuric acid on the plastic in the first place, rather than going through this whole, well, let's dissolve it first rigmarole, or let's dry it first and then chunk it up and then put it in the distillation and then, come back out the other end with the a salt and then reacidify the salt. But hey, that's his way of doing things, so like it worked out for him and I'm happy that he made the content about it. So yeah, if you enjoyed his video, I would very much recommend watching his other content. The other chemistry content is just as interesting because it is, kind is on the borderline of accessible, does kind of weird fun shit, making hot sauce out of plastic gloves and all that kind of stuff. Yeah, I would say go watch NileRed. It is a good old time. The finale will involve mixing the toilet paper moonshine, the glue alcohol, and air alcohol together to make the ultimate forbidden mixed drink. You can't forget the obsidian skull that also goes into crafting that to make the obsidian ultimate forbidden mixed drink. That's important. So yeah, I think that is going to conclude things for tonight. Wow, that took me almost double the runtime of the video to do a full reaction to. I am pleasantly surprised by that. I think that's actually what I was expecting, but it is also like kind of crazy I had that much to say. Yeah, thanks for sticking around and listening to me kind of ramble on about the video and all that good stuff. Adding some Peeps wine would be good for some flavor into that mixed drink. But yeah, we'll be back next week with more Mega Man RPG on Monday. and some more Doom TNT Evolution on Tuesday. If I feel real up for it, maybe I'll do another chemistry reaction video next week. But I'm maybe not. I'm 50-50 on that. We'll see. But yeah, have a good night, everybody. I'll see some of you next week. And till then, goodbye.